Good morning, dear students. Today we are having the second practical lesson. The first one was about basic methods of integration, and today we will integrate rational fractions and some irrational functions. Today we will start with integrals that can be found with extracting perfect squares. So the first example is the following. So we don't have such integral in the table of integrals, but we can find the perfect square of in the denominator, and then use differential entry technique. Here is the double product. So 2 by 3 over 2x. Uh, plus 9 over 4. So uh, 3 over 2 in square and minus 9 over 4. So now we can extract so we can collapse this expression, write it in a more compact way. So here is square. So it will look like this. So the same. And minus 9 over 4 minus 10, so it minus 40 over 4, it will be minus 49 over 4. So it will look like this. And it is similar to the following integral. So table integral. And it equals 1 by 2a logarithm of module of the following fraction. So a plus x and a minus x and plus c. So this expression under integral needs also to be modified a little bit. So what will we do? First of all, we will put minus before the integral, so to change the order here. Oh, yeah. So incorrect for placeholders. So we'll do like this. And let's actually rewrite this fraction to the following form. So 7 over 2 in power of 2. And this expression will be moved under the differential. So now everything what we need we have. So now we can integrate this fraction. So minus 1 second. So divided by 2a. So multiplied by 2 over 14. And so the logarithm, the following. Oh, I guess that here is a mistake. Oh, no, not everything is okay. So logarithm. So 7 over 2 plus this expression, and 7 over 2 minus x minus 3 over 2. So now let's simplify it a little bit. Yeah, and plus c. Don't lose constants. So 7 plus, so x plus 5. And here 2 minus x. Any questions about this exercise?
In the lowest formula you wrote, it's from table, yes?
Yeah, this is the table integral.
But I saw table integral. Okay, I understand.
Maybe there is a function u, yeah, so that is
Yes.
complex. Yeah,
No,
so
I didn't see square root, so I mistake.
ah, yeah, but we don't have a square root here.
Yes.
Yeah, there is a similar to it, but also table integral. More questions?
And how we get the third row after last integral of second row?
So this, yes?
Yes. Короче, интегрировать.
Okay.
Yeah.
So this is so 1 second, one so 1 second, and we divide also by a. A equals 7 over 2. So we multiply by 2 over 7. And also this expression can be taken into brackets. So I moved this expression x plus 3 over 2 under the differential. So that we did on the previous lesson. Have I answered your question?
Yes. Thank you.
Okay. More questions?
Can you scroll up a bit? Yes. No questions.
Okay. So let's continue. Let's move to the next task. I will skip exercise B because it is the similar, but we have the square root, so it will be in another table integral. And in exercise C, it is more interesting. So this is for your, so you will solve in your own. So first of all, let's extract the perfect square. It's quite easy here. So plus 1. And it will be the following. So x plus 1 in power of 2 plus 1. So done. But that's not everything that we need for now. So we need to do more actions. So let's split this integral to a difference of two integrals. So in the following way. So 3x dx minus this integral. And what do we see here? Here actually we have the table integral, so we just need to use the differential entry technique, but we will not hurry with it. And here, so if I write this expression that is under the root, so in the numerator we can see something like the differential of the expression that is under the square root, but that's not the differential, because the differential of this expression equals so 2x plus 2 dx. So we need to modify this expression to suit the differential of the denominator. So let's do it. First of all, I will move 3 out of brackets. Yeah, and I will multiply by 2 and divide by 2. So the equality is not broken. And also, not in order not to break the equality, I will add 2 and subtract 2. And also don't forget about this integral. So, what I have, so yeah, I will move this 2 out of brackets, minus 2 out of brackets. So what will I receive? So 3 over 2. What's going on? Yeah, understood. So because of levels. So sometimes it works not as expected. Okay. So I will leave it like this. And what about this minus 2? So I will move it out of brackets here, and I will receive, so actually the same fraction as this, so the same integral like this, but another coefficient will be. So I need to multiply minus 2 by this coefficient. So I will receive here minus 4. Oh, no, not here, but here. So minus 4 of this integral. So now we can so now we can use the differential entry technique, and what we will receive. So here in the numerator we have the differential of the expression under the square root, and for this integral we will also move x plus 1 under the differential. So it's okay for us. And now we can integrate. We have integrals that suit to table integrals. So the first one, so it's we integrate like a power function. So 3 over 2 multiplied by 2 this square root. And what about this expression? So minus 4. And we have such integral, so logarithm of so the, x plus 1 and plus this square root plus c. So actually this is the final answer. Of course we can cancel, so we can, so it's good idea to simplify, so just to cancel 2, and we will receive 3 square roots. So that's it. Any questions about this task? How this logarithm appeared? So basically this is the table integral.
No questions.
So here we use the combination of perfect square and differential entry technique.
Understood.
Okay, good. If no question, let's move to the next exercise, and we will use the other approach. So we will have other uh, fractions. So in this exercise, we need to find integrals by finding isolating the integer part of the integrand. So for some cases we have incorrect fractions. Okay, I will better skip A, so B will be more convenient to show you how to. So it needs less calculations, and I will show you what I mean how to solve it. So how to isolate the integer part. So this fraction is incorrect. So what does it mean? So the degree of x here is greater than in the so in the degree of x is greater than in the numerator, greater than degree of x in the denominator. So now I need to divide numerator by denominator, and to leave in the denominator the so we can so must remain only x in power of 0 in such case. So only constants. And I will remind you how to divide. So x square plus x plus 1 and divided by x plus 1. So dividing x squared by x, I will receive x. And now let's multiply x by this expression. So x squared plus x. So here I will receive 0, so 0 plus 1. And basically what do we have here? So 1 will remain in the numerator, and x will be just so will be added to this fraction. So you will see what I mean right now. So x plus 1 over x plus 1. So if I again, if I transform it to the common denominator, I will receive the following fraction. So x multiplied by x, so x squared, x multiplied by 1, x, and plus 1. So we know how to integrate it. So this is the sum of integrals. So I can even split to the sum of integrals, of course, just to remind you some properties of the integral. And basically, yeah, so dx, but it can be replaced with dx plus 1. So the same, but it will be the table value. So 1/2 x square plus logarithm of module x plus 1 and plus c. So any questions about this exercise?
No.
Okay. So A and C are done analogically. So for A, only x in power 1. So x in power 1 and lower can be in the numerator, and the same for C. So in the numerator can leave x in power 1 or less or lower. So you will do it in your own. And now we will use another approach. Method of undetermined coefficients, or maybe you remember something about it, so how to solve it. So we see that here is the product of some expressions in the denominator, and we don't know how to integrate products. There is no specific rule like for derivatives, but we know other approaches, and this approach is the method of undefined coefficients. So I will rewrite the fraction in another way. So actually, so this product is the common denominator for some unknown fractions. Well, I use D because I don't want to mix it with constant C, but you can use C, but it will be also a good idea to maybe to mark it in another way, like this wave or head or anything else. So these coefficients are unknown. And that what we have here, this is the product. This is the result of, so this is the sum of these fractions. So now let's move again to the common denominator. So A will be multiplied by x plus 3 and by x minus 4. B will be multiplied by x minus 1 and x minus 4. And D will be multiplied by x minus 1 and by x plus 3. Now let's expand brackets. So for A, what do we have? X squared minus x minus 12 for B. So x squared so minus 1 minus 4 minus 5x plus 4. And for D, so x squared plus 2x and minus 3. And now let's expand brackets finally. So ax squared minus ax minus 12a. Done. Plus bx squared minus 5bx plus 4b. dx squared plus 2dx minus 3d. And after that, we need to regroup these addends according to degrees of the of x variable. So what I mean? So for x square, a plus b plus d. So these coefficients a, b, and d. For x in power 1. So minus a minus 5b plus 2d. And for power of 0, so minus 12a plus 4b and minus 3d. So what we received? So we regrouped all these addends. And I have a question. So what do you suggest to do next? By looking at this expression and this. So the next logical step. What do you think about? So any ideas? Daniel, yeah?
We need to substitute x by numbers in denominator. That, for example, x minus 1 equals to 0, we need to substitute 1.
I don't clearly understand. So substitute x, maybe anything else. So okay, give me the
We need to say
example.
that these coefficients are equal. A plus b plus d equals 2.
Yeah, so yeah, I understood. Yeah, actually, so a plus b plus d equals 2. Minus a minus 5b plus 2d equals 41. And minus 12a plus 4b plus minus 3d equals minus 91. Yeah, so maybe I understood something in so incorrectly before. So we actually have the system of linear algebraic equation with respect to these coefficients. Yeah, let me check. Yes, so equals minus 91 here. So be careful with the signs, actually, by the way. So it is important. And for now, I will not solve completely this system. So using all known methods, I will just look the answer in my materials just to save our time. So we already know how to solve systems of linear equations. But of course, when doing your homework, so you will have to solve them in your own. So we just skip to save our time and pay attention, pay more attention to integration. So received such coefficients, and finally, so which integral do we have as a result? So it will be expanded by sum of three fractions. So 4 over x minus 1. So now this coefficients are known. So minus 7 over x plus 3 and plus 5 over x minus 4. Yeah, and dx. And we have table integrals. Yeah, so we know that we can move. So x minus 1 can be moved under the differentials, but I will not waste our time to expand brackets. So you know what I mean. So we have table integrals, but it will be moved under the differential. So this and this separately. So that now we will skip writing such details. So we have such sum of logarithms. And this is the final answer. Any questions about this exercise?
No.
Okay, let's move next. So we will have another case of method of undetermined coefficients. So again, so let's expand. So let's factorize the integrand. So using undetermined coefficients method. So here we see that x minus 1 in power of 2. So such a fraction of complex multiplicity, and how it is handled. So firstly I write the first power of 1 and then power of 2. So if it was power of 3 here, I would also write plus c by x in power x minus 1 in power of 3, but we have only power of 2. So doing the same that we did before, the same approach. So x minus 1, so finding the common denominator, plus bx plus d multiplied by x minus 1 in power of 2. Again, so expanding brackets, so 4a. So ax squared minus ax.
Sorry,
Yeah?
but
Question?
why d multiplied in x minus 1 in power of 2, probably in power of 3, because
Oh,
x minus 1 in x minus 1 square.
stop. So no questions about this point, right?
Yes.
Okay, so d is, so we need to find the common denominator. It looks like this. So what is missing for d? So x minus 1 in power of 2. So we need to multiply it by x minus 1 in power of 2. So
Okay, I understand. I thought that under a we also need multiply by this denominator.
yeah, so for a, just x minus 1. So because we have x minus 1 here, so actually we multiply what is missing. So the same that you did at school. So more questions? Or so have I answered your question?
Yes.
Mhm.
So,
Okay, so moving next. Plus bx plus dx square minus 2 dx and plus d. And now let's regroup as well. So for x square, a plus d. For x in power of 1 minus a plus b minus d. And for power of 0 only d. Okay, now again solving the system of linear equations. So a plus d equals 1 minus a plus b minus 2 equals minus 2d equals 4 and d equals 4. So we even can solve fast this system. It's simpler that in previous exercise. So a equals minus 3. And what about b? So what do we have? So 3 plus b minus 8 equals 4. So b equals 9. And now again, so now we have everything that we need, and let's write the transformed integral. So minus 3 over x minus 1 plus 9 over x minus 1 in power of 2 and plus 4 over x dx, and writing down the solution. So minus 3 logarithms over module of x minus 1. So here minus 9 over x minus 1. So integrate power function, and plus 4 logarithms over x of module of x plus c. Any questions about this exercise?
No.
Okay, and let's solve one more exercise, one more case of undetermined coefficients. So you will understand what is the case here. So x in power of 4 minus 1 dx. So first of all, what do we have to do? First of all, we need to factorize the integrand. So we need to factorize the denominator. And how can it be factorized? So x squared plus 1, and so x squared minus 1. But x squared minus 1 also can be factorized. So this expression is equal to this. So I just use a formula of squares of so difference of squares. So in this case, so we have so we cannot expand we cannot factorize x squared plus 1 anymore because we have no real roots for equation x squared plus 1 equals 0. So no real solutions. So then we use another approach. So x squared plus 1, and here ax plus b. So it's written like this in such cases. And here we here we will do like did before. So c okay, let's use d over x plus 1 plus e over x minus 1. And then doing the same actions. So we just find the common denominator. So ax plus b multiplied by x square minus 1 plus d multiplied by so x square plus 1 and by x minus 1 plus e multiplied by x square plus 1 and by x plus 1. So now expanding brackets and regrouping all addends. So for these brackets, so ax in a cube minus ax plus bx square minus b. Then plus dx cube minus d plus dx, stop. Yeah, and minus dx square. So nothing lost for d. And what about e? Ex cube plus ex square plus ex plus e. So firstly, grouping power 3. So a plus d plus e. And what about power of 2? So b minus d plus e. Now power 1 minus a plus d plus e. And power of 0 minus b minus d plus e. So everything is here, nothing was lost. And now writing down the system of equations. Which we will not solve for now. Just we will look into the materials for the lesson. So 1 0 1 1. And now let's look which results do we have. So the solution of the system. So a equals 1 over 4, b equals 3 over 4, d equals 0, nice, e equals 1 second. So let's write down the integral, so how it transformed. So 1 over 4 over, so x divided by x squared plus 1 dx plus so 3 over 4, but without x, so only dx here, and d equals 0. Nice. So less to integrate, and so plus 1 second of integral, so dx by x minus 1. So now we can integrate. So we have a sum of table integrals. This integral can be taken as so with the using differential entry technique, but you have it in the table. So for the first integral, logarithm of 8x squared plus 1, pay your attention that I don't write so I use not module but usual brackets here because this expression is always positive. But if you write module, it won't be the mistake. So plus 3/4 arctangents x and plus 1/2 logarithm of module x minus 1. So here we need to use module because we don't know the sign of this expression. And plus c. Any questions about this exercise? Maxim?
Can you please scroll up?
Yeah. So here?
I did not understand, or I just missed, how did we get ax plus b in the first fraction?
We use such approach when we have such square roots that so we have when we have such expressions in the denominator so which have no real roots. So in this case we cannot factorize x squared plus 1 anymore. So yeah, some cases can be, so if it was x in power of 4 plus 1, so we had to find, so we would have to write down coefficients for x cube, x square, and x in power 1. So we find coefficients of possible x that so for possible powers of x that can be in the nominator. So we pay attention to that. So we don't forget that this fraction must be correct. So have I answered your question?
Yes, I understood.
More questions?
Can you scroll down?
Sure. So which point?
I need to finish writing the answer.
And what about calculate the integral? Or you want to write down the answer of the system? So more questions, or you have no questions?
No questions.
Okay, so do you need the board still, or I can clear it? Okay, let's do the following. Let's have a break for 5 minutes. I will not stop the screen sharing, and everyone who wants to look at it can do it. And now let's have a break. And then we will integrate irrational functions. Okay, let's continue. I guess that everyone finished writing down. So now we are moving to integration of some irrational functions. Actually, all rational fractions are integratable, but what about irrational functions? Not all of them. Mhm. Yeah, everything. So here it seems to be a mistake. Okay. Yeah, because of sequence of writing down. But so yeah, look better at it at home. So here we use different sequence of coefficients, so it affects the final answer. So yeah, pay attention to these materials. Okay, so now let's integrate the first irrational function. And the idea is to solve it with using substitution. Well, square root of x multiplied by 1 plus, that's not under the integral. Yeah, another level. So x plus cube, 1 plus cube root of x, and all this in power of 4 dx. Okay, so let's do the substitution. Yeah, let's mark it as I. So the substitution is the following. Yeah, I will need to write this integral like so. Roots in order to be written like fraction, fractions in power. So 2/3. So how do we choose the substitution? So how to decide how to substitute? We need to substitute the least fraction. So we need to substitute the x in power of 1 divided by the least fraction. So the common denominator. So the common denominator for 2 and 3 is 6. So we do like this. So t equals x in power of 1/6. Then then x equals t in power of 6. Dx equals 6x or 6 t in power of 5 dt. Then so x in power over 1 second so it equals t cube, and x in power of 2 over 2/3 equals so it equals t in power of 4. Oh no, t square. Stop. No. Yeah, t in power of 4. Yeah, so like this. Stop. Something
But
is.
why x in power of 2/3? Там де 1 плюс
Oh, so numerator is the
One probably.
one, yes, that's yeah. So now everything is co is correct. Yeah, really. So yeah, and I think what is wrong. So thank you for your attention.
Будьте здорові.
Дякую. So writing down the uh, a new fraction. So t in power of 3 multiplied by 1 plus t square, and this fraction, or this expression in power of 4, and multiplied by 6 t in power of 5 dt. And now let's move 6 out of brackets. Here we have t in power of 8, and here 1 plus t in power of 2, and this expression in power of 4 dt. Well, unfortunately, we have, so we need to expand brackets here, because there is no way to solve it in another way. So no approaches. So we can, so nothing to enter under differential sign, or so integration by parts will not solve, will not help us in such case. So we need just to expand this expression. So now let's do it. So t in power of 8. Yeah, and by the way, to find coefficients, let's use Pascal triangle. So I guess you know it from the school, but let me remind you. So this is for power of 0, power of 1, power of 2. So just reminding you that we add in, so we add 1 plus 1 here, and from the left and from the right, we always write 1. So these are coefficients that we need for power for polynomial. So for not such not big powers, we can use such approach. Plus 4t square plus 6t in power of 4 plus 4t in power of 6 plus t in power of 8 dt. And now let's move t in power of 8 under this expression. So here is t in power of 8. So 10, 12, 14, 16. And now let's integrate. Okay, so 1 over 9 t in power of 9. So we rationalized the integral, and we have just the polynomial instead of such not understandable roots. So 4 over 11 t in power of 11 plus 6 over 13 in t in power of 13 plus 4 over 15 t in power of 15 plus 1 over 17 in t in power of 17, and plus c. But this is not the final answer. We were calculating integral for function that depends on x, but here is the integral function that depends on t. So there is two ways. We return to old variable x with using such formulas, or I suggest you another variant, so you don't need to return to x for such expression, yeah, for fractions, because you can make a lot of mistakes, so we can just write like this, where t equals x in power of 1 over 6. And that's it. So you can do it in your individual home tasks. That's okay. Absolutely, that's not a mistake. So this is the final answer. Any questions about this exercise?
No.
Okay, if no questions, let's move to next part, B. So we have some time to solve more exercises. This panel is a little bit annoying. So B, so then, oh, okay. Do we have time for B? Okay, let's do B and C. Yeah, we have enough time. So square root of x and so cube root of x in power of 2 and the root of power of 4 of x and dx. And let's write it like powers again. So x in power of 1 second. Here is x in power of 3 or 2 over 3, and here x in power of 1 over 4. And again, making the substitution. So here we have the common denominator for these fractions, 12. So 3 and 4, yeah, so 12. So we do the following substitution. X in power of 1 over 12 equals t. And so substituting all these expressions. So t equals, x equals t in power of 12. Then dx equals 12 t in power of 11 dt. X in power of 1 second equals t in power of 6. Okay, moving next. So x in power of 2 over 3 equals so just a moment, t in power of 8, and x in power over 1 over 4 equals t cube. So it seems that everything is done. So writing down the new rationalized integral. So t in power of 6, yeah, and let's multiply it by 12 t in power of 11 dt. Then t in power of 8 plus t cube. And now let's simplify it a little bit. So 12, so t in power of 17 dt. And we also can cancel t cube. So here will be t in power of 14, t in power of 5, and here 1. So we have such incorrect fraction. Let we not let we not waste time on dividing it and just look into the example of the into this solved task. So what do we have here? So 12 integral of so t in power of 9 plus t in power of 4 plus such interesting fraction. If you look attentively at it, you will notice something convenient. So that this fraction will be not looks such scaring, so scaring. So maximizing. So here we have the differential. So in the numerator we have differential of this expression in the denominator. So let's expand it a little bit. So 12, I will write it like sum of two integrals. But this fraction will go away. We will use it in other integral. So 12 over 5. And now what we can see. So this is the differential of this expression. So if we differentiate, so yeah, so 4 in power of 4t cube plus 3t squared plus 2t plus 1 plus 0. And now we can integrate it. So now let's integrate. So 12, so t in 1 over 10 t in power of 10 plus 1 over 5 t in power of 5 plus 1 over 5 logarithm of module of t minus 1 plus 12 over 5. And again, we have the table integral, so logarithm of this expression plus c. So, and don't forget to return to old variables. So we can write only like this. So any questions about this exercise?
How we get 12 over 5? I don't understand.
12 over 5.
Yes.
But I expanded this sum, so 12 coefficient before this integral.
Okay, I understand.
Yeah, so be attentive, everyone. Don't lose the coefficients in order not to get to receive mistakes. More questions? Okay, if no questions, let's move next. So one more exercise. So x dx. So one more interesting case. So x square root of x plus 1 plus cube root of x plus 1. So x plus 1 in power of 1 second, x plus 1 in power of 1/3. No, not power here. Yeah, I just press an F1 instead of 1, so that's why it's always appearing. Okay, so here I have to do the following substitution. T equals x plus 1 in power of 6. Then x plus 1 equals t in power of 6. X equals t in power of 6 minus 1. Then dx equals 6t in power of 5 dt. Now, what about expressions in brackets? So x plus 1 in power of 1 second equals t cube. And x plus 1 in power of 1 over 3 equals t square. So everything is taken into consideration. So nothing is lost. So now writing down the new integral of a rational function. So instead of x, t in power of 6 minus 1. Dx here, and t cube minus t, oh no, not minus, plus t square. Oh, stop. Stop. 6. What's going on? Yes, something was lost. Control C. So okay, now okay, t cube plus t square. Now let's simplify this integral. So I will move 6 out of brackets. Yeah, this integral is simpler than previous two. So I can cancel t square, so t plus 1, and here t cube by t in power of 6 minus 1 dt. And we can also eliminate the denominator. How can we do it? First of all, we will use the formula of difference of squares. So t in power of 6 minus 1 equals the following. So t in power of so t cube minus 1 multiplied by t cube plus 1. And then we can factorize t cube plus 1. So t cube plus 1 equals t plus 1 and t square minus t plus 1. So canceling denominator. And this multiplier. So we have just a polynomial. Of course, I will not waste time for expanding brackets manually. Let's look into the solved exercise already. So t in power of 8 minus t in power of 7 plus t in power of 6 minus t in power of 5 plus t in power of 4 minus t in power of 3. So it seems that everything is okay. So now we will integrate this expression. So now 1 over 9 t in power of 9 minus 1 over 8 t in power of 8 plus 1 over 7 t in power of 7 minus 1 over 6 t in power of 6 plus 1 over 5 t in power of 5, and finally minus 1 over 4 t in power of 4, and plus c. And to make this answer final, we need to write write down what does t equal. So t equals x plus 1 in power of 1 over 6. Any questions about this exercise? Okay, and now just look how it looks like if we return to old variables. So return into x. So not such convenient expressions, and here the same, and here. So you can just write so where x equals something depending on t. So any questions about this exercise, about the whole lesson, about the previous lesson?
No questions.
Okay, so if no questions, have a nice day, stay safe, goodbye. So I will publish a lesson later. Goodbye. Thank you for your attention.
Bye.
Have a nice day.
Goodbye.
The
Thanks.
lesson. Goodbye.